Let's now see the city location. It tells you where it is located. It could be in the switch gear, as I mentioned, either before the circuit breaker or after the circuit breaker, or both before and after the circuit breaker. As you can see, here is my circuit breaker. Here is its primary pole that connects to the bus bar, and its secondary pole that connects to my cable. It comes here first, exits the bus bar, enters a current transformer, then exits the current transformer, and connects here to the cable termination end where my cables are connected. If I am on a GIS, as you can see, this is an example of a GIS book quote, which is a double pass. Double bus, single breaker. But of course, it is a 3-pole, as you can see, meaning each phase is supported on its own pole. So you have a current transformer, and there is one here, as you can see. This is a pole, but only after the breaker. However, sometimes it is both before and after the breaker. Very nice. Okay, let's take a look at the nameplate, and this is the actual current transformer that, God willing, we will work on tomorrow. I have now the current transformer nameplate. To read it, I simply look at it, and here I have the manufacturer, for example, or the company we got it from, the serial number of the current transformer, the order code, whatever. These are some of the details you work with for the current transformer. All right, but let's take a look at the other parts. Here it says something called P1 over P2, or P1, P2, 400 over, or 400, 1000. Then there's some text written here. Okay, so now I'm talking about the current transformer nameplate, the current transformer nameplate. All right, now let's carefully examine this engineer. Initially, the current transformer, whether it is the window type or the bushing type or whatever type, ultimately, you will have your primary circuit and then you will have your secondary circuit. We will draw your secondary circuit irrespective of the iron core. The secondary circuit appears like this. Like this, all right, and like this, and like this, all right. The current transformer is nice. As you can see here, like this, when I explain to you, it is written for you that it is P1 and P2. It is written here, for example, P1, or drawn on the current transformer P2. All right? These are the two terminals where the input and output of the current are. So it tells you this is P1, primary 1, and primary what? And primary 2. So it tells you that primary 1 and primary 2 will have a current, or the transformation ratio of the current transformer will convert from a current value of 400, all right, or 1000. 400 or 1000 to how much here? It provides you with three things in this manner. Very much so. It brings you here a number, then a code, then another number. The code here is S, which stands for secondary. All right. And the number here, and there's a number here. This number is not forgotten. It represents the core number, and the second number is the tab number. So just so we don't forget, the whole idea is that you have what we specifically call, what we know, which is like this, and wrapped around it like this, is the iron core that is wrapped around, right? Great, engineer. This type sometimes is referred to as having the core inside a molded case. The molded case, as engineers say, is essentially that inside the same box, there can be two cores, two iron cores, meaning inside there are two iron cores. One could be for protection and the other for metering. Here, both could be for protection or both could be for metering. It means it's in a molded case, like a molded body or shell with the internal components inside. Both have an iron core. All of them are inside a single box with terminals coming out. So inside there are two cores. For example, this is the first core, let's say core 1, and this is core 2. One could be for protection and the other for metering, or vice versa. Both could be for protection or both could be for metering. Great, very nice. So here, when I tell you core number, don't think that there's only one core inside and that this core does two things. No, core number means inside. This molded case, there are more than one iron core. Great, very nice. So what does this mean? Core number 1 or core number 2. Then tap number. What does tap number mean? It means you have a number of turns, these turns. And here you have something called a tap. Tap number means it gives you 3 numbers here, for example. It tells you 1 here, 2 here, 3 here. Just like here, it tells you 1 here, 2 here, 3 here. This tap means a terminal. All right? If I tell you, for example, 1S1, it means I am referring to the first core, the first tap. Okay? 1S2 means the first core, tap number 2, 2S3 means the second core, the third tap, and so on. All right? So the conversion rate that he wrote for you here, which is either 400 or 1,000, see, I'm pointing at it with the pen, 400 or 1,000, is linked to the tap number. What does that mean? As you can see down here, I'm pointing with my mouse. Here it is. 1S1, 1S2, 1S3. It means that 1S1, all right, 1S2, 1S3 means if you are leaking, it means that 1S1 is all right, 1S2. 1S3 means if you are, do you want to take a conversion ratio of a quarter to a quarter? I wrote to you how many 1 ampere to 1 ampere. Or do you want to take a conversion ratio of 1,000 to 1 ampere? That's fine. You have 2 choices. If you want a quarter to 1, then take the one that is with, meaning you take with yes, meaning you take 1S1 with 1 S2. All right. And if you took 1S1 with 1S3, then you are converting from 1,000 to what? To 1. Why? Because you have taken the larger number of turns here, and therefore you are doing a step down in a greater way. So if you took 1S1 with 1S2, you are taking from 400 to 1. And if you took 1S1 with 1S3, then you are taking from 1,000 to 1. And similarly for, so this is core number 1, and this is core number what? This is core number 2. All right, we're not forgetting anything. Very good. So this is the idea of the conversion. So P1, P2 are the 2 terminals you have here, which are the primary of the current transformer. Here you will have the hole through which you will pass your cable. So here, it will tell you where P1 is. This terminal is P1, so the other side is P2. It specifies the direction of P1 and the direction of P2. Great. After that, we understood how the terminals are labeled and how to achieve this conversion. Very good. Excellent.